All right. So yeah, 2:35, and we are here on November 6th. So yeah, your midterms are going to be marked first, and then your assignment twos will be marked. I think that's, probably people are more interested in their midterm mark. This Saturday, tutorial 6 is due, but assignment 3 is not due for another couple of weeks. I've also released tutorial 7, so you have all of the tests sort of associated with this assignment. So yeah, I think, I don't know, that about covers it. Any questions on the schedule? Okay, so last class we were talking about polymorphism, and then I was going to do a polymorphism example. Just to refresh your memory, we had something like this. We had a game where a hero and an orc jumped back and forth across a single line of text and tried to stab each other. And so yeah, the idea was that we liked the game, but we had gotten to a point where our current design was no longer useful. One sec. Right, so we had reached a point, we had made the game, but now we wanted to expand it even more, and we realized our design was sort of standing in our way. So how do we fix that? Well, we started by looking at our two characters, hero and orc, and realizing that they had a lot of code in common, right? So all of their member variables and most of their member functions were the same. Some of them, and most of them, were even implemented the same, but some of them were implemented a little differently, like print and update. Okay, but we have the tools now to fix those things. And how we're going to fix it is a particular way called refactoring, where we take a superclass out of our two base classes, where the superclass contains all of the shared attributes. And then the update and the print, since those exist in both the hero and the orc, but they're slightly different, we're going to make those pure virtual. So this is going to be an abstract class. And to begin with, we're simply going to do that. All right. We have an algorithm that runs, so our battle updates every time until one of these, the hero or the orc, dies. And then after we do this refactoring, what we want to do is we want to adapt our algorithm to be more general. And then once it's more general, we can add other characters and do some other fun stuff with it. Left off last class, and we had looked at, I had shown you some of the code and I'd shown you some examples, but now at this point, we want to get from here to here, and then we'll see where we are. So refactoring is this idea that I take my code, I redesign it, and I don't change any of the functionality, but this new design is better in certain ways. In this case, it's going to be better in the way that it's going to allow me to add new types of characters very quickly. Okay. So orc, we want a character class. Okay, no, I don't have my little script here, so we'll just make that from scratch. It should be okay. So character.h, and we want a character.cc as well. Okay, and in my character.h, of course, I'm going to want things like header guards, and all of these includes. So I'm going to copy these over. And then class character. All right, so that's a good start. Now, if we look at the hero, well, one thing we noted was that all of the member variables of both hero and orc are the same. So we can move all of those up into our character class, right? So we're going to start with our hero. We're going to move most of the functionality up into our character class, and then we will convert the orc after. So what I'm going to do here is I'm going to take those away and put them in character. But let's make those protected. Protected so that we can share them. You know, we're not so sophisticated yet that we're going to, you know, there are design patterns so that we can keep these things private and still access them, but yeah, and that's all. All right, I'm going to turn off Copilot for now. Stable. Okay. Okay, so the next thing we want to do is we want to take, well, let's keep things consistent here. So I want to include the character class. And then I want hero to inherit from the character class so that as I move things over from hero to character, I still have all of that functionality. Yeah, sorry, public. Not a class or struct name, huh? Okay, so there is, anybody see the error? This is sort of common when you do this thing where you copy and paste classes from one file to another. You might run into stuff like this, probably you have, but yeah. They have the same header guards now, which means that the compiler can't read both of these files in. So I got to change this to character. And then that should, I still don't like it. End if, oh yeah, end if is missing. Okay, so we're good so far. This get position, get swing, get avatar, these are getters, they're very simple. Get hit is dead. These are all the same between hero and orc, so I'm going to move those into character. We most likely want some sort of constructor, and so the hero takes avatar, health, and position, so our character will take avatar, health, and position. Okay. And yeah, and then we talked about how update and print, they're going to be different between the two classes, the orc and the hero. So we don't want to make any assumptions in this case. We're just going to make this a pure virtual function, as well as okay. All right, so now we can, yeah, it's complaining about all this. We're just going to simply move it into the character class. And then the update we will keep, and print we will keep. Okay, so our character class is shaping up now. Here virtual and our hero. Right, so I don't have this, first of all, well, I do have access to these. So I could have made a no argument constructor in my character class, but I didn't. This avatar is string. Sorry, one sec. It's in character. Yeah, okay, so the avatar is a string, so but we can still sort of hard code these values, right? So I can pass in H 20 for health and 0 for position, and that will take care of updating all of these things. Yeah, I think I can cast it to a string maybe. Okay, I'm going to cheat a little bit here because I think this will convert for me if I just leave it as a string. Char engine. Oh, sorry, I'm a dummy. That should work. Okay, fine. Yeah, I was trying to throw a character in there because I had originally specified a character, but yeah, so it's supposed to be a string. Those are the string. Great. Okay, so now my hero initializes all of his member variables. I still have the old update function. I still have the print, and I still have this special collide function that is exclusive to the hero. Again, I don't necessarily have to do this for functionality, but in order to make my code self-documenting, I'm going to add the virtual keyword here so that whoever's using it realizes that these are virtual functions. And yeah, so we made a bunch of changes. We introduced a new class. I moved a bunch of code into that class. I didn't change any functionality, or I shouldn't have. This should still work, right? So let's give that a try. Of course, it's upset with me for this reason. Yeah, I'm good, thanks. It doesn't know what a character is. That may not be the only problem, but it's at least one problem. Oh yeah, the last thing, of course, is I did forget to do this. Health H and position P. All right, try that one more time. Okay, so it compiles. It seems to be working fine. So I've refactored it. I've changed the design of my code. I'm not quite done, but I've changed the design of my code, but I have not affected how it runs. Questions so far? All right. So now I'm going to do the same thing for orc. Orc's going to be a little easier because I already have my base class. But yeah, I do want to call, not here, sorry. I'm going to inherit from character. Okay, I can get rid of all of these things. These are already in my character base class. I can get rid of all of these. These are already in my character base class. We'll add virtual here. And we really just want the update and okay. So now our orc also inherits from character. That was a lot easier now that I have the character base class. All right. And yeah, again, refactored, same functionality. Okay. That's great. We haven't changed any of the core algorithm yet, but if we want to add more characters, we can. Adding more characters, of course, would involve changing my battle class. And I don't want to, I'm going to have to change it regardless when I add a character, but I want it to be as general as possible and as easy as possible. So what I want to do here is I want to take this algorithm and update it to run on a collection class full of character pointers. So I want it to run on the general base class. It's going to make general function calls. It's not going to be perfect. It's still going to be pretty ugly. If I really wanted to, redesign this, there was a lot more steps involved, but at least we'll see the beginning of it. So I want to update this algorithm so that instead of calling on hero and orc directly, we call on a vector of characters, which means that we want a vector, we want the characters, we will get character through the hero.h and orc.h, so that's okay. And I'm just going to call it CHS. So this is a statically allocated vector, but of course, in the background, vector is allocating arrays on the heap. So it's going to be, it's going to take up minimal amount of memory in my class. Okay. And then here I want to say push back. We're going to keep it simple to start with. The orc, and then what's it, hero. And if I wanted to really generalize this, I would read these in from a config file or something, right? And so all this would read from the config file, and then all I have to do is change the config file, and voila, I have different characters or more characters fighting. But yeah, okay, so I have my characters on my vector, and now I want to adjust these. So is the battle over? I have to keep in mind that there might be more than 2 characters. And so the battle is going to go until there's only 1 or 0 characters left alive. So I'm going to keep track of how many characters are dead. Sorry, not back. Size. If okay, so for every character that's dead, I'm going to increment this dead variable, and then the battle is over if there's one, if the difference between the living and the dead is 1 or 0, right? So I'm going to say return vec.size is the number of characters. Sorry, not vec. Minus dead greater or less than or equal to 1. Right, so it's true if there's 1 or less than 1 character left, and false otherwise. Okay, it's a little more complicated than what we had, but now this works for any number of characters. Okay, here board reset, that's fine. These updates should be easy. A lot of things now are going to be in a loop. I'm just going to loop over all of them and call update. Okay. And now I should consider some other consequences of having more than two characters. There might be a bunch of dead bodies laying around, right? So maybe this isn't the best way. Maybe I should say if CHI, if the character is not dead, then I will update them. Otherwise, they can just, yeah. Otherwise, if they're dead, I want them to appear red. I'll say board dot set red. Okay, so if they're alive, I update them. If they're dead, I want to color them red on the board. They're going to stay still and they're going to be colored red and just lay there. Okay. All right, so far so good. All right, so I should have some comments here, but the comments would be print the weapons to the board, which I do first so that I write the characters over and then print the characters. And now you can start to see the pain of this design, right? So this is written as like a lot of systems languages. This is how you would do it. What I would really like to do is say, make these guys into game objects or even characters. And then I would either call board.print character, and then the character will supply all the necessary information and abstract. I wouldn't have to do everything in a multi-step fashion like this. We might look at that a little bit later, but for now, we're going to do this in a bit of an ugly manner. So yeah, all I'm going to do here is, so this draws the weapon again, sort of in a very clunky way, but CHSI. Okay, and then that handles all of these. I can delete. And then I want to do the same thing for their avatars. Its position. Yeah. You can really kind of feel how, in general, this sort of fine-grained passing of arguments into my board, into my view, is really a terrible design, right? But I could just update everybody all at once and figure out everything inside another function. All right. Who gets hit? Let's make it ready. Let's see if Copilot will do this for us. So this is, I need to check. Everybody is going to try to fight everybody, so anybody might be getting hit at any given moment. Can I bring that online? Okay, so yeah, I want a double loop so that everybody can swing at everybody else. So there's a couple things going on here. I do a double loop. I make sure somebody's not trying to hit themselves, right? So whatever your weapon is, we pretend that you're skillful enough that you don't injure yourself. So if I is not equal to j, that means these are different characters swinging at each other. One character swings, and if it's a hit, it returns true, and that character takes damage. But the other thing is I'm going to set that board position to be red. Okay, so again, it's a little more complicated than what I had, but this is a nice generalized algorithm where I can add new characters and everything's going to work great. This I'm not going to touch for now. I could do something, but let's just get cut to the chase here. Well, you figure it out. Well, it almost figured it out. So I just want a loop. I don't need that divider everywhere. I want to loop and print out all the characters. Finally, this print result. Yeah, so there's only either one winner or everybody is dead. So I'm going to say oops, dot size. Yeah, that's it. So yes, Copilot was very wise in this case. So at most one character is not dead. So if I find a character that's alive, that character is victorious, and then I'm going to return. If everyone is dead, then I will get to here and I'll say everyone is dead. Okay, so now I've sort of generalized the algorithm now. Let's make sure it still works, and then we'll try adding another character. Okay, so the orc's victorious. They're in opposite order now. The hero's victorious. They collide. Yeah, it still looks to be working. And ostensibly, perhaps, possibly, we have a nice general algorithm that will work when we add another character. Okay, question so far? All right. Okay, so let's add another character. Let's make a wizard and wizard.h. Let's steal some code from, say, the orc. We want all of this. Make sure that this is perfect. Okay. Now the wizard is going to behave a little bit differently. All right, settle down. The wizard's going to behave a little bit differently. The wizard's going to move slow like the orc, but they're going to have a fireball, and the fireball they can throw anywhere on the board, right? So the fireball will be thrown at random, and but I'll steal the movement from the orc class. Still unhappy about that, eh? Oh yeah, end it. Okay. Since I've inherited from character, I really only have, well, I have a constructor and I have a update. And I have a print. I think that's it, eh? Yeah. So, all right. So then all of the work goes into wizard.cc. wizard.h, and then okay, so I want to call the character constructor and pass in my avatar, which is of course a W. My health, I think, is what, a 10 or something. Position, I'm not sure. We'll put them at 2 to start. They might get stabbed right off the bat. Okay, so the update as promised, I'm going to steal some orc code here. So update the position of the wizard. And then I want some hero. I want, what does the hero do? Oh yeah, I want to throw steal a little bit more here. Okay, so the swing, the fireball is pretty powerful. It does a bunch of, what do we say, 1, 2, 5 long. So then my left position is going to be this thing. So I want the fireball to land somewhere at random on the board. So I'm going to define a variable, which is the position of the swing. And now this is just simply going to be, sorry, the left should be pos. And the right is position +5. The damage is 10, and this is looks like when it prints. So yeah, I ostensibly have a wizard class. We'll see how well this works. Doing it off the cuff like that. I do have a finished version in case I get something wrong, but okay. So the wizard walks slowly. He's kind of weak, but he's got a very powerful fireball. So now I can just go into my battle class. I can add a wizard. And then in my constructor, I'm simply going to, yes, doesn't know what a wizard is. Is a inaccessible. H is okay. Well, we'll try compiling it and see what happens. Gives a similar error or not. Okay, so I have a wizard. The wizard has behavior. I don't have to change anything else. I've already done all that. Let's see if this is a real error. Oh, my wizard is private. Yes. In fact, everything is private. Okay. One last thing I forgot, or rather, everything in C++, changes have to be propagated everywhere. So I need to compile my wizard and include it as one of the object files. Oh yeah, and then the hopefully last thing that I should do is make a print function. Okay. Oh yeah, so the wizard got slaughtered right off the bat. But yeah, you can see I have another character. I should make sure, so you can see also that their fireball keeps appearing on the screen. I should really take that off. Let's try that again. Oh, those guys really killed each other. All right, the fighting is a lot faster now. That fireball is something else. But yeah, ostensibly I have 3 characters fighting. Again, I should disable that fireball once the wizard is dead, but you can see here that it works. The orc is victorious. Yeah, so, and that was easy, right? I just made a few lines of code. I decided how to implement the update. Now I have a wizard class and I can add other classes. Yeah. Questions? Yeah. Yeah. Simply, again, it doesn't affect the functionality whatsoever. If I left these off, they would still work. I just do it so that somebody looking at my wizard class, they know that this is a virtual function, right? Because I declared virtual in the base class, but maybe, if they're not looking at the base class, I mean, who goes down? When you're using a class, it's sort of unusual to go all the way down the class hierarchy and check. So yeah, I want to give an indicator here that, yes, this is a virtual function. Now you can go check which base class it made it virtual, but yeah, it's just an indicator to the other program. Other questions? Okay. Still not happy about something. Okay, there we go. All right, so that is, yeah, we wrote a game, we just kept it simple. We didn't solve problems that we didn't have. We reached a certain stage and we decided that our old design was no longer working. So we refactored, which means we didn't make any changes to the functionality, but we introduced a more advanced design that allowed us to do things like add new characters quickly. You can see here, when I tried to, let's see, in the curses version, yeah, I did some updating to the design. So I have a game object. So I have this add game object in my board because it was getting really complicated. I had to pass a lot of things in, and really you just want 2 objects talking to each other. That's it. So yeah, a more advanced design, especially when you have to draw something, is you use sort of this double dispatch thing, or not double dispatch, sorry, like a visitor pattern, which we'll talk about why in the next section. Okay. Okay, so that brings us to design patterns. So now we know how to do polymorphism. We know how to write general algorithms and sort of make our life simple. Polymorphism is one of the ways that we can introduce design patterns into our code. There's other aspects of design patterns, but yeah. So we're going to talk about some of the major categories of design patterns. We're not going to go too deep into them. In 3004, you will probably take a lot more of them. We're going to stick to some very simple ones in this class. So we're going to talk about the facade, which is easily one of the simplest. It's really, in some sense, just polymorphism. We're going to talk about the observer, which is another very common one, especially with things like GUIs. Right, so when I click a button, there's a bunch of things that might want to know that I clicked that button on the screen, and they can all register and be observers. We'll talk about factory. So there's a lot of ways that creating things maybe is not ideal just in a constructor. So we want to make a whole class to handle that. And then we'll talk about anti-patterns. This is really just, I mean, we won't really talk about it too much, but this is essentially bad programming. Or not bad, I mean, we all start by just writing and seeing if things work. But anti-patterns is in some sense coding yourself into a corner where things are a big mess. So what is a design pattern? It's a way of organizing code to address a common problem, right? So there's a bunch of ways we can organize code. Inheritance and polymorphism, right? That nice general interface now of a character eliminates a lot of problems. Delegation via composition or composition alone. So we did see that with our stack class, right? We had we delegated some of our stack functions to the vector using composition, also using inheritance. We can just implement certain operations. So yeah. So what happened was basically, I don't remember when exactly, but there were some people in programming, and they got together and talked one day, and they discovered that, you know, they had the same solutions to common problems. So they named these design patterns, and then they wrote a book, and then they became sort of famous, and then, yeah, and then everybody in university teaches you from that book, basically. It's one way to, I guess, be rich without having to do too much extra, is write a famous book that gets used over and over again. So design patterns are meant to address change in, well, I mean, we saw that, right? So we redesigned our code so that we can change things easier. So often that's what design patterns do. This is not really 100% true. Design patterns do other things as well. So yeah, the book is Design Patterns, Elements of Reusable Object-Oriented Software, written by these four people, informally known as the Gang of Four, which I think has to do with Chinese politics. I'm not sure. I don't remember. Historically, there's some group called the Gang of Four, and these guys were sort of nicknamed after them. I don't remember all the details, but yeah, so this book sort of became famous, and it sort of you know, coined the phrase design patterns, and then everybody's been using it ever since. And it's not that there's a set number of design patterns. You can discover more design patterns as more problems come up. The ways that we deal with them, we have to come up with new solutions, but they sort of use a lot of the same old tricks, right? And by same old tricks, I mean a layer of abstraction. That's basically what it is. But so types of design patterns, there are creational. How do we make an object? There are structural. This is sort of, yeah, how objects relate to each other. There's behavioral. This is how objects talk to each other. And there's architectural, which is arguably sort of something separate from design patterns, but basically stuff like model view controller and things like that. So when we talk about design patterns, we refer to the client class. This is the class that's in some sense using and benefiting from the design pattern. Yeah, so creational design patterns. So this specifies how to create objects. We can have factory, abstract factory, Singleton. So a singleton is, well, if we looked at our game, we have a battle class, but we should only really have only one instance of that battle class running, right? We never want two, not in the way we designed it. So a singleton might be a good design pattern there where we say, basically we make the constructor private and then we make a public function, get battle class. And then we make sure that if there's no battle class, we make one and give them a pointer to it. If there's already a battle class, we just give them the pointer, right? So we can make sure that there's not two battle classes running, which would sort of mess up our game. Factory and abstract factory. There's a bunch of reasons why we might have a factory instead of using new. We'll talk about some of them, but there are things like object pools, right? If I have a game, deleting memory and allocating memory is slow. It's going to slow down my game if I do too much of it. So what I might do is I might have a bunch of pre-allocated objects. And then when I need a new game object somewhere on the screen in the middle of the action, I just grab one of the old ones, I initialize the values, and I pass it back. And I can do that in a factory. There's other ways that factory gets used as well. Structural design patterns, how objects relate. So inheritance, composition, right? These are the two things that we are mainly concerned with on our UML diagrams. So examples of those are facade, bridge, decorator, proxy. So facade is arguably the simplest. It is sort of the most vanilla design pattern you can have. But the decorator is kind of cool. If you used Java, you've probably used the decorator, and maybe you didn't think it was cool at the time because it is a bit of a pain. But if you want to do things like read and write from a stream, you have things like stream buffers, and you wrap them in stream readers and writers, and then you wrap those in buffered writers, and so that's sort of a decorator pattern. I don't know if they still do that. I just remember it used to be a huge pain to read and write from files in Java. Bridge, I honestly don't remember. Proxy is, I call a function, and the function is actually implemented across the internet, right? But I have a proxy object that acts, it sends out the call, it gets back the information, and it behaves as if it's an object, a local object, essentially. All right, so behavioral, which objects or how objects communicate, which objects call which. So observer pattern, strategy, visitor. We're actually going to see an example of the strategy pattern. But again, observer is, we've sort of talked a little bit about it. You register with a GUI component. So whenever somebody clicks it, a bunch of different things might happen. Everybody who's registered gets notified, and then I decide what happens. Architectural is basically how we group things together into subsystems. So it's sort of the larger style, I guess a higher level view of our application. So yeah, client server, peer-to-peer, model view controller, etc. All right, so facade is a structural design pattern, and it basically, I provide a simplified interface for a complex class. All right, so this is sort of, what exactly do I mean by that? Because that is a very wide umbrella, right? That includes polymorphism. But yeah, so what happens in general is the client class makes some simple operation or calls some simple operation on the facade. And then the facade goes behind the scenes and makes a bunch of complex calls and calculations and what have you, and then comes back with the information and behaves as if it was a simple operation, regardless of how complex it was, right? So yeah, we're basically to a facade class. And you could sort of, these definitions are a little wishy-washy, but sure, you could think of Python as sort of a facade to the C language, right? It's an interpreter, has an interpreter, and it interprets what you write and makes a bunch of calls to C functions. So Yeah, the UML, simple enough. I have a client class that's going to call on my facade class, and my facade class is going to have a bunch of complicated classes and figure out what calls to make and how to fulfill my request, basically. Another example of a facade, if I read and write and open a file, and these are very, very simple calls in C and C++. But if I go behind the scenes and look at sort of the drivers and the operating system calls and things like that, there's a bunch of very complicated stuff going on, right? Right down to the hardware, where it actually grabs it off of my solid state driver or whatever. There's a bunch of device drivers in between there. There's a bunch of things going on that I don't really care about. I just make a very, very simple call. Please read this file or write to this file. The observer design pattern, it's a behavioral design pattern. And again, it's, I have some subject class that I have a bunch of observers who are interested in some event that might happen to that class. And when that event happens, the subject class notifies all the observer classes. Right, so the observer classes, their job is they subscribe to the notifications. And then when they get notified, usually with a callback function, they update themselves or do some other task or whatever. Yeah, this is also known as the publisher subscriber model. And it's often used with model view controller, right? So when changes are made to the model, we call the view and we update it. Right. So the UML of the observer pattern might look something like this. I have a subject, and my observers can subscribe or unsubscribe to and from the subject. When something happens, the subject calls notify, and that notify goes through all the observers and calls update on them. Right. So this observer is a general base class, a abstract class, and then these concrete observers, they have their update function called, which means in a model view controller sort of design, they would get their state from the subject. But that's not necessarily what has to happen. For an observer, we just really have this subscription and notify model. So an example might be a game, right? So view maybe not the best, but yeah, let's say that I have a bunch of people playing Fortnite, and they each have their own view at the game. Maybe if they're living, they have a certain view. If they're dead, they might have another view. But all of these views register with my central game. And then when something happens, I notify these views that the state has changed. These views call update, which gets the state of the game, and then they can update their view, and so on and so forth. Okay, question so far? All right, visitor pattern. I really like the visitor pattern. I'm probably not very good at explaining it. So it's not critical that you get all of this. So we're going to just look at a couple of examples. What a visitor pattern can do is it can sort of give you internal access to another object. We'll talk about how. The other thing it can do is it can resolve this what's it called? Double dispatch problem. So yeah, I have a function. My function takes two arguments, A and B. One is of type visitor, one is of type element. So how do I resolve, if I have different types of visitors and different types of elements, of course, then I'm gonna have a bunch of different functions that I have to call. So if it's visitor type A, I call one function. If it's visitor type B, I call a different one. And same for the elements. And so, if I look at all those combinations, there can be a lot. So how do I resolve this? Well, I could do like a table lookup, right? It's not that easy. If these are all element A and element B are both members of element, then my general function might be function element visitor. And now I have to resolve what's the actual type. So yeah, this visitor pattern will resolve that. basically my visitors have this visit function that passes in an element, and then the compiler can decide which visit function to call based on the element that is passed in. And then those elements will call, not good. This is a better, we'll start here. So I have my element that will accept a visitor. And I'll have two different accept functions, right? So one is accept visitor A, one is accept visitor B. And then inside those functions, I call visit, and I pass, actually, sorry, this is fine. I have one function with the general type I call visit, but this visit is of course using polymorphism. Dynamic binding calls the correct visit function for the correct type of visitor. So if it's visitor A, it calls this visit. If it's visitor B, it calls this visit. And it can also resolve which type of element that is, element A or element B. Like I said, I like this pattern. I need to find a better way to describe it. If you don't get it, I understand. I might throw a very simple example into one of the assignments to help you, but yeah, questions? Yeah, all right. Yeah, so one of the ideas behind it is like, if I have to collide, I have spacecrafts and asteroids, and a collision between a spacecraft and an asteroid is different from a collision between a spacecraft and a spacecraft, or an asteroid and an asteroid. So we can resolve this multiple dispatch problem using the visitor pattern. But factory is a creational design pattern. This is used for how an object is created. So, you know, maybe I'm reading some stuff from disk, and I'm reading, before I make my object, I'm going to read a config file, right? So I don't want, if I just have a simple class like a photograph or something like that, the photograph should know about config files, you know, what type of system it's on, how it's going to be displayed. So I'm going to call on a photograph factory, and the photograph factory is going to be, it's going to look into all of those things, right? So all of these questions before a thing is made so that I can make the proper type, the factory can answer them and then give me back the photograph, right? So that's sort of the idea. One of the ideas behind the factory is that it might depend on stuff that my class should not know about, right? My class should not know about operating system calls, or what kind of encoding well, maybe the encoding part, but yeah, it shouldn't know anything about the operating system. So then my factory can know those things and then spit out the proper kind of JPEG or whatever. Yeah, so we encapsulate the creation of derived objects. Our base class is often abstract, and then yeah, we get our factory. I just say, give me one of these base class things, and it figures out the right one to give me and gives it to me. So yeah, Stack Overflow, there was a nice little piece on it. It said, if you think of classes as people and the factory as a hiring agency, right? So I want to hire somebody, but maybe it's not permanent. So I don't want to think about things like whether they are, you know, eligible to work in this country, or whether they have the right criteria, the right skill set. I'm going to rely on my hiring agency, my factory, to fill in all those details for me and just give me the right person for the right job. So yeah, that's I kind of like that analogy. But so the UML, I have a client. The client uses a factory, so I make a call, give me some type of product. The factory looks at whatever it has to look at to decide what type of product. It makes that type of product and then hands it to the client, and the client uses the product, you know, using polymorphism through this base class handle. It never has to know what type of concrete product it is. So another example I like for this one, video games. And I'm in a village, let's say, and I need to generate a villager. So my villager factory is going to look at, well, where am I? Am I close to a shop? Am I close to someplace where kids might be. Am I close to a monster, a thief, something like that, right? So the villager factory will give me back a villager that has some specific implementation, and then I pass that into my game, and the game keeps running the same general algorithm, and I get this nice specific behavior out of my villager. All right, so finally, anti-patterns. These are just bad programming practice. So a common one is I have one class, I try to do everything in that class instead of breaking it down, right? But again, anti-patterns, it's not that you're a bad programmer, it's maybe whenever you start, you almost always carry a little bit of technical debt, right? You want to solve the problem, but you don't quite understand it yet. So you just do it in the most straightforward way that you can, and then you come back later and redesign it, right? So the problem is if you don't come back and redesign it, then you get some really bad looking code that's hard to update, hard to debug, things like that. All right. So those are design patterns. We're going to do an example of the strategy design pattern next. First, we're going to talk a little bit about it, but any questions so far? Okay. Okay, so we've talked about polymorphism and some of the problems that it solves, and then that led into design patterns, because a lot of design patterns use this polymorphic, this base class handle to a concrete subclass. Now we're going to look at a specific problem of encapsulating behavior and how we can solve that, which design pattern will solve it. And spoiler alert, it's the strategy design pattern. Okay, so yeah, polymorphism is a mechanism behind many design patterns. Basically, abstract interfaces are often behind design patterns. So this layer of abstraction between something and another thing. So yeah, we're going to use the strategy design pattern to implement behavior classes, and we will get to, So a behavior class is a class that implements a behavior or algorithm. So why should we want that? Maybe you noticed object-oriented programming is great. It solves a lot of problems, but sometimes it's kind of rigid, right? So I make a function in my class. And yeah, what if I want to change how this function operates, right? So I have a certain behavior, maybe whatever it happens to be, a sorting algorithm, or I swing a sword, or a different type of weapon, which is going to be what we're looking at. I want to be able to change my character's weapon, basically. So how can I do that dynamically without hard coding it into my object? Well, I'm going to have a function, swing weapon, and then I'm just going to forward that swing weapon call to a behavior class. And then if I change my behavior class at runtime, I can change how that function operates, right? So it's again this idea of dynamic dispatch, but now it's within my object. So an example, again, video games and wild outlandish characters. But let's say I have a game character and I have, I don't know, played Gloomhaven for a little bit with my brother, not very much, it's way too complicated, but it had some cool characters. One of them was called an Inox. It was a big bull-like thing. Inoxes some were good, some were bad, like anything else. But yeah, we had different types. They were archers, they were shamans, and they were fighters, right? So using our object-oriented programming, we get this class hierarchy, so we can get these different types of behavior from my Inox, similar to our video game where we had the hero, the orc, and the wizard, and each has their own behavior. The problem is I also have this player over here. This player is a little more generic. What I want is the player to be able to pick up a weapon and use it, or maybe pick up a spell and use it, or pick up a bow and arrow, which is also a weapon. So I want these abilities that I have in my Inox, I also want them in my player when the situation calls for it. So what can I do? Well, I can, this class hierarchy, I can duplicate a bunch of code. right, between my player and my Inox, or maybe I can move all that code up into game character. That's fine. But now if my player wants to change weapons, I have to get a whole new player object. I don't want to do that. So I want to be able to change weapons without making a major change behind the scenes. So yeah, this is the previous example on the previous slides is the traditional approach, this using inheritance and polymorphism. The problem is it's not very flexible. It doesn't allow us to change the behavior at runtime without actually swapping. I make a copy of an entire object. That's expensive. So I just want to change one little aspect of that object. So what we're going to do is we're going to encapsulate our behavior inside a behavior class. Our entity, our character, will delegate that behavior to this behavior class. And then if I want to change my behavior, I simply change which class I'm pointing at and dynamically change the behavior. So now my new UML will look something like this. I have a game character. I still have these subclasses, and I could enforce this in my Inox if I want. You know, they're just NPCs, so they don't have to be as dynamic as my player character. But in my player, or regardless, I'll have a move behavior, or as this should be an attack behavior. So I'll have this attack function now in my base class, whereas before it was in my base class, but it was virtual. Now it's in my base class, but it is a concrete function. And all that concrete function is going to do is I'm going to have this attack behavior, and I'm going to call the attack function on my attack behavior. And then that will, using dynamic dispatch, call one of these and decide how I'm attacking. All right, so the advantage is we can introduce new behaviors without changing existing code. Right, I can make a new weapon or a weapon type. The same way I made a new character, now I can change behaviors that easily, introduce new behaviors. We can reuse and share existing behaviors, right? Change them easily at runtime. If I pick up a different weapon or change my weapon, I change the behavior easily. There's still a problem with the memory. We must allocate and deallocate behavior objects to change the behavior. And memory allocating and deallocating is not cheap, but we'll ignore that problem for now. There are solutions to it, like again, a pool of objects that we can share. All right. So back to our battle class, but not here. Where were we? Yeah, I think it's this one. All right, so this is the same example we were looking at before. Let me just make sure that it runs. All right. So yeah, it still runs. There might be some subtle differences from what we implemented, but basically the same thing. We have three characters, a hero, an orc, and a wizard. The hero gets killed right away. So there's a long battle. So we want to introduce, well, what I want is I want my hero to be able to shoot fireballs if they want, or use the orc weapon, or the orc to use the sword, or the wizard to pick up a sword, whatever. So I want to be able to change these behaviors dynamically at runtime. So I'm going to change my character class to do that, right? So yeah, still in the right place. So my character class, the update is what decides on the position and you know, the behavior of our weapon. So it decides the position and the behavior of our character, but also the weapon. So what I'm going to do actually is to sort of help us with this example, I'm going to divide this into two updates now. So I'm going to have the regular update, and then I'm going to have update weapon. And this is, as you as I pointed out in the UML, this is no longer a pure virtual function. I'm actually going to have an implementation here. In fact, I don't even need this virtual. I mean, it doesn't necessarily hurt to make it virtual in this instance. But yeah, so let's say I'm going to make it not virtual and probably won't cause any problems. And then in here, I'm just going to call, I'm going to have some sort of, well, I have a swing type. I'm going to introduce a weapon type, and I'm going to call weapon update. Okay, so let's just weapon.h. A bunch of this. Okay, so we're going to keep it simple for now. We're going to have, we're not going to really put an implementation in right now, but weapon. And this weapon is going to have an update function. And this update function. So our weapon class is going to be abstract, so we're going to make this a pure virtual function. Okay, so this is going to be the sort of the skeleton of this weapon class. We're going to add some attributes and some specifics to it later. But if we go back to our character class now, when our character wants to update their weapon, they're going to call, well, first of all, I'm going to make a weapon pointer. Okay, and then I'm simply going to call weapon update. Okay, there we go. And that's it. So now I've made my behavior class. It's an abstract class at this point. I've hooked it up with my character class. This update, or this particular half of my update function, is now no longer virtual. It's a concrete function, but it still calls on a virtual function. So I'm still going to get that dynamic dispatch at runtime. At runtime, it'll figure out which weapon type it has and then update appropriately. All right, questions so far? Okay. What does our weapon do? Our weapon will contain the swing object, and when I call update, it's going to update that swing object. Is that what I want to do? All right, I don't remember the solution. Let me see. Yeah, so we have a swing inside of our weapon. That's going to call update. So our swing is basically like a struct, right? It just holds the data for us, but it's all related data, so it holds it all in one place, which is convenient. So yeah, I'm going to want this get swing function here. And yeah, I'm going to need to pass in the position because when I update my swing, it has to know where to draw it on the board. So yeah, we will add those things to this version. Perfect. Does it know what a swing is? Maybe not. We've got 5 minutes left. Let's see if we can do this. Okay, so This is our general base class. We have a concrete get swing, and then we have this virtual void update. This should take a position. And then we're simply going to make a bunch of other classes in this same file just to make our life easier. So we'll say class sword, for instance. There's a weapon. And yeah, virtual void update. And I'm going to, instead of having weapon.cc, I'm going to do everything in this .h file just to make our life a little bit easier. So what does our sword do? Well, right now our hero holds a sword. So if we look at the hero's update, based on a direction, I'm going to choose a random direction. I'm going to choose a random direction, and based on that random direction, I'm going to swing either left or right. Right, so that's my sword, and I'm going to the position was passed in. So in my weapon, oh yeah, inaccessible, sure. So let's make this protected. Voila. Okay, so we have a sword. What is the problem there? Spell position wrong. Okay, we have a sword. Now this sword will, it will update exactly the same way that the hero's sword updated. We do have to pass in the position, but that's fine. That position corresponds to the position of our character. So now in my, let me make that change in the character class. Yeah, we have that there. Okay, so perfect. Wait, this is the complete. Yes, the whole position. All right. Okay, so we have the basic structure now. We're going to have to introduce this update weapon. I mean, you know, I don't really want to do this, but just to make this a clear example of a strategy pattern, I am going to change the base algorithm, which is sort of what we're trying to avoid. But again, you know, sometimes you have to make trade-offs. So in my first update here, I'm also going to call update weapon. And then everything else should be the same. So this character get swing, instead of returning swing, I'm going to return the weapon swing. Okay. So yeah, that was, I had to make one small change to my algorithm. Again, it was, you know, sort of damned if I do, damned if I don't there, but I wanted to clearly describe the strategy pattern instead of maintaining that. All right, so we didn't really we have a sword, we can give everybody a sword at this point. But we're running a little low on time, so next class, we will finish up this example. We will give everybody some weapons and maybe swap them out. And, you know, we'll have a game that runs a little bit better than it did before. That's it for today.